Hi, everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast. We recorded this one live on March 13th, 2012, for release on March 14th, 2012. My name is Chris, and joining us, like every single week, is our host, Heather. Hey there, Heather.
Hello there, Chris.
Hey, happy science to you.
Happy science.
What do we have coming up on the SciByte today?
Today, we're going to take a look at the recent solar activity, new ideas and imaging on the Titanic, Higgs Boson particles, dinosaur feathers, transparent electrodes, dust devils on Mars, viewer feedback, and as always, take a peek back into history and up in the sky this week.
That sounds like a great episode. I am really happy that we're going to talk about the solar flare stuff that's been going on, because that has been all over the news.
Yes.
And it's one of these stories that I know people have probably heard a lot about, but maybe they don't know all the details. So I'm looking forward to jumping into that. But I thought I'd share with you. One of the things I learned today, and I just thought this was an interesting science fact, so I'd share it with you.
Okay.
Is today I learned that Titan's atmosphere is so thick and the gravity of Titan is so low that humans could fly through the atmosphere by flapping their wings, or by flapping wings attached to their arms.
Oh, wow.
Yeah. Yeah. Unless you have wings, then you don't have to have anything attached. But I don't have wings. Yeah. So I didn't know that about Titan, but it sure makes me want to go on some sort of space tourism. And, would you like to take the fly through the atmosphere course? Yes, I would.
Well, it's one of those things. I know on Mars, chickens could fly.
Oh, lucky chickens. I mean, actually, unlucky chickens. They had to evolve on a world where they can't fly.
Yeah.
So they kind of
unlucky us if we're on Mars and they have chickens.
It's true.
They can get everywhere.
That's a good point. You know what? I think that only leads us to one thing.
What?
It's time for the news. All right, what is our first news story today?
Like we were mentioning before, it is all the solar activity that has been going on. This story is a story that has never ended. I started it and have added something to it every day for 5 days.
That's intense.
It was like, there was a big thing that went on, and then it happened again, and it kept going. So
and we've talked about solar flares on the show before. In fact,
yes.
Haven't some of the ones we talked about on the show before been some of the largest that we've observed, at least for a very long time?
Yes, and again, this one is one of those I believe it's the largest for this year. And so this is another big one, and it was a 1-2 punch. It was a large one, and then another large one. Actually, the most... So, a large X-rated, X-class event, which is the strongest of the flares that can happen. It occurred on the Sunday. About an hour later, another one was let loose. About 5 times smaller, but still in the X scale. So it's a huge one, and then an hour later followed up by another one.
I was on, I think it was Reddit, and there was threads going where people were freaking out, like, how many hours do we have? What's going to happen? We're going to have is it going to be like an EMP? I mean, people are kind of worked up about solar flares.
Yeah. Well, it's every time a big one comes along, you do have the scientists on that say the right one at the right time with the most power could wipe out all satellites. Some of it is just to say, be aware we need to have these plans in place to make sure that we are able to move in precision, but it also scares everyone, and they think that every time there's a solar flare that the world is going to end and their GPS will fail them and they won't be able to get to work. Right.
So, I mean, how do we know as just laymen's if it's something we need to worry about? I mean, what tools are available to us?
There are websites that will tell you. There's a link at the bottom of the show notes, spaceweather.com, that will tell you, what just happened, how strong it is, what the likelihood of aurora are in the next 48 hours, and that kind of thing. But, we're learning more and more with these. We have various satellites looking at the sun now. We have a 360-degree view, and so we're learning more and more about these so that we can maybe kind of predict them.
Okay.
And some of these, it's kind of interesting because you see those spots and you don't really get, a real feed on it. But this week they had a picture of, the size of Jupiter and the size of the Earth next to one of those solar spots. And you're like, huh.
Yeah, it gives you an idea of how large they really are.
Yeah.
I mean, those solar flares, Earth is just a tiny speck on there. I mean, that's scary to laymen's like me.
Yeah. Now, the solar flare itself is bright shine, and it gives off a whole bunch of energetic particles. the coronal mass ejection is what the animated GIFs, you see that big whoop come off, and that's like actual, more like particles, not like actual stuff, parts of the sun that just kind of sloughed off.
Yeah. Okay.
So they're definitely connected. So coronal mass ejections, cloud of particles, they go along magnetic field lines. And this one, the stronger of the two hit. Now, it hit with a lot less oomph than they expected. They were expecting something to happen and just happened. It was a lot lamer than I thought it would be, which was kind of good. But what happens is if the magnetic fields in the coronal mass ejection or in the, if the magnetic fields line up just right to the Earth, then it's toned down. It's much less. So if the magnetic fields line up just right, then it kind of passes through without too much problem. Now, towards the end of this one, it kind of amped up a little bit, probably because the magnetic lines didn't line up quite as well.
Oh. Huh. That's such a small little detail for something so far away, it seems. But I guess not. I guess it's not that small. Yeah, so
these, and another two exploded on Saturday. So 6 days later, another two, not quite as large, but another two fairly big ones erupted again. It's all from this same area, this same solar spot area. So this is just a really active region. It had two big ones on Saturday. 6 days later, it has another two fairly large ones. In fact, it had an effect on some of our probes. The one around Mercury, there's an image of it. It's like, it's taking pictures, and there's all sorts of specks and speckles and streaks through the image. And that's the energetic particles hitting the camera's CCD and sort of, igniting those bits of the CCD that send the images. So you kind of see the snow of the effect. In fact, there's a European spacecraft around the Venus Express going around Venus. It had such intensity that it actually blinded the spacecraft. It has an onboard star tracker. It's been blinded by these kind of things 5 or 10 times.
Blinded by the light?
Yeah, blinded by the light. But this one is kind of unusually long. At most, was shut down for 32 hours or so. Now, it's not like it's going nowhere. It drives by the star tracker. But when it does go blind, then the manual operations kick in. Scientists here can still orient it and orbit it safely.
That's good. It's not all is lost from the.
No, you kind of have to prep for things like that.
You'd hope they
especially when you put things closer to the sun, like Venus and Mercury. You kind of have to do what you can to protect the instrumentation.
Yeah, and
then make for backup plans to say, all right, if we lose this part of the spacecraft, what can we do? And if we lose that part permanently, what do we do? It's one of those that they have to make a whole bunch of contingency plans. Because the sun is a crazy thing.
The sun is a
giant
crazy thing.
Ball of very hot reactions going on. And so it can send off all these energetic particles. Not only do they, it creates aurora, it has the chance to disrupt the electrical field so that it can interrupt satellites. They had one, years back where it interrupted the electrical grid of Canada and the Northwest United States, Northeast, if I get my areas right. Mm-hmm. So these are things that can happen, and that's why some of these scientists go on and they say, "Look," and they wave their
for good ratings.
Well, ratings plus the scientific community wants to make people.
They want to scare people a little bit. They want to scare people into preparing.
Yeah, you kind of have to scare. Yeah, like you said, you have to scare a little bit so that it'll light a fire under these, the power companies and the satellite industry and all these different people to kind of make contingency plans. Like, what if we had 3 hours to say we're about to have a high energetic event? Because solar flares travel very fast. Coronal mass ejections, we have a little bit of time to to prep for. These satellites that we have around the sun give us a much better idea of what's going on and kind of give us a better idea of where it's going. Is it pointed towards us? Is it pointed just slightly away from us? But we still have events where we might go, these solar flares and the hydrogenetic particles come to us a lot faster, and we have to be able to move quickly. If it's a big enough event, then it would be good to have contingency plans, say power grids. Could you pull some of them off? Because if you pull them off the grid and shut them down and you have this event, then you can turn them back on and they'll be okay. But if they're on during when some of this happens, they'll ground out and you won't be able to turn them back on.
So quite literally, a contingency plan in some cases might just be turn critical gear off. Yes. Unplug it from the wall, that kind of thing. It doesn't have to be like these crazy shield the building with some sort of protective...
Tinfoil?
Yeah, tinfoil. Grab the protective tinfoil, Timmy. Doesn't have to be
Quick,
like that.
Grab a whole bunch of rolls of tinfoil and run around your house. No, it's not quite like that. I mean, theoretically, sure, you can unplug things from your wall, but it's more like the power company itself.
Okay.
It needs to take, maybe if they take, half the grids in the country down.
So what it sounds like what you're trying to tell me is I shouldn't be worrying about it as much as some people might be leading me to worry about it, at least as much as I saw people on Reddit. People on Reddit were really freaking out.
Well, yeah, sometimes people on the internet freak out. But yeah, I mean, they're trying to make the power companies do something. It's one of those things where you want to get the people moving also so that they can go, maybe to their politician or to the company and be like, hey, do you have a contingency plan? Are you even thinking about what to do in this kind of a case?
More grassroots, try to get people to go to the people who need to make the changes. Okay, all right, I'm following you now.
Kind of work at it in multiple ways.
So does this always usually translate to some really spectacular Aurora Borealis? I'm not sure.
Aurora Borealis or Aurora Australis? Sometimes. This one, like I was saying earlier, the magnetic field lines, they didn't line up. They lined up just right.
Oh, I see.
That's what they had much less aurora than they thought they would.
So without them lining up, you don't get quite the show.
Yeah, it all depends on how the magnetic fields line up. If they line up just right, then it's a lot brighter and you have more interference. If it's lining up,
when you were saying earlier that it kind of depends on how it hits the Earth, that would also obviously make a difference in the show that you get. Okay.
Oh yes.
Okay. Duh, that makes sense.
Yeah, so it depends how directly it's aimed at us. Are we getting a corner? Are we getting the main brunt? How are the magnetic lines all lined up?
Right.
So there's a lot of things going on.
Interesting enough. And, it is the year 2012. The chat room was speculating that perhaps the biggest storm yet is to come in December 21st. Dun, dun, dun.
And the solar activity high is next year.
Or late this year.
Next year.
So you're saying the sun is betting that we'll still be around for 2013.
Yes.
Oh, okay. Well, that makes me feel better.
I'm planning for episode, 37 plus 1 year.
I gotta tell you, I've been planning my finances accordingly to run out of money by December 22nd. So I got a real problem. No, I'm kidding. But actually, speaking of finances, is there anything else you want to cover on that one before we jump on?
No, I don't think so.
All right, then why don't we talk a little money here, folks? In fact, if you want to donate to the Jupiter Broadcasting Fund to stay afloat after December 21st, 2012, I kid, but actually there is a way, as a listener, you can help support Jupiter Broadcasting. If you go over to the website and scroll all the way down to the bottom, we've got affiliate links there now. We've had these for a little bit, and if you click there, you can, before you shop, say like at Amazon US, UK, Newegg, ThinkGeek, Best Buy, Mint.com, Audible.com, which I love. If you click there before you shop, it tags your entire shopping session to support Jupiter Broadcasting. Additionally, we now have a Chrome extension there, which is great because you install that Chrome extension, you don't even have to think about it. We automatically get credit, and a lot of you out there are doing this, and I really want to say thank you because it's helping while we don't have very many sponsors. But on top of that, some of you out there are just doing like the office supply purchases for your business and things like that. That kind of small stuff really adds up. So thanks to everybody who does that. And if you would like to help out, all you have to do is just go over to our website and scroll down to the bottom and click before you shop. And that's it. It makes us money. Jupiter Broadcasting, the way it works is all of those companies, we have an agreement where they give us a small percentage of your shopping session. It's anonymous, so I don't know who did it. And then I just get the monthly payout. And it's a great way to give us something without costing you anything while you get yourself something.
Always makes me feel a little bit better when I give gifts and a little bit better when I buy myself stuff.
Yeah, it's like, I might be getting myself a treat, but at least you.
But it's also giving it's something to somebody else. It's like,
I like
good.
that.
It makes me feel better.
All right, well then I think it's time for the SciByte News Bite. I think that's my favorite news bite bump the news bump that we have right there. All right, so what is up first in the news bite today?
How the moon might have affected the crash of the Titanic.
Wait. Are you telling me Titanic versus the moon? Really? This is really?
Yeah.
Okay.
Yeah, I saw this and I had my skeptical pants on.
Okay. But it passed the sniff test, huh?
Yeah, it did.
Right,
there was an unusually just a really good alignment. It's a really uncommon alignment known as the spring tide, January of 1912. It's when the moon and the sun line up in such a way that gravitational pull enhances and you get abnormally high tides. So the tides are abnormally greater than normal.
So, and this happened on the night the Titanic hit an iceberg?
January. It happened in April. So a couple months earlier, had a very high tide.
Okay. Oh, but maybe that moved some stuff around is what you're saying.
Yeah. So they started looking. They're like, hey, this happened then. What if, the tide rising, it can cause, obviously, things to happen on the oceans.
Stuff to travel, for example.
Like glaciers. Or icebergs. So icebergs normally, they travel down the coast to a certain part and they kind of stop. And it takes them years to kind of float down and stop and refloat and go. But the unusually high tide in January would have been enough to dislodge a lot of icebergs, such that they could travel the southbound ocean currents much faster and much lower, which would have meant they could go faster, explain why there was an abundance of icebergs in April of 1912. They would have been much more abundant, much more southern than you might imagine. That was being the norm.
That might make sense why even some experienced crew members weren't really taking that seriously, the threat of icebergs, because maybe they hadn't experienced a lot of, I don't know, I'm just trying to think outside the box.
Obviously there were a lot of events and the moon didn't, cause them to ignore, all the evidence saying, hey, watch out, don't go fast, and all the other things that happened.
Yeah, that was kind of a big mistake.
Yeah, but this is one of those things where there were a lot of contributions to this. And it kind of was interesting to note that even the moon itself could have helped move all these icebergs into the area.
I'm reading this Stephen King book about how this guy that goes back in time and does time travel. And through the book, there's these different ways where essentially history doesn't want to be changed. And so there's just a lot of things that happen to make sure certain events that are epic and important just happen. And this would play really well into that book. I mean, so all of the icebergs, maybe there was more icebergs out there because of the position of the moon a month ahead of time. They're going faster than they should have. All of these different random components come together and deliver disastrous results.
Yeah. Even Doctor Who has those. They travel back and forth in time. There are specific events that he can't tamper with. They just are unable to change. Because they kind of are locked in time. They have to happen for things to, for things to go on in the way they do. Kind of like that, where you have to have the right series of events happen for history to move forward in the correct way.
Yeah. Huh.
Another interesting thing that came out about the Titanic is they've recently assembled most likely the first comprehensive map of the entire 3x5 mile debris field. Sonar imaging more than 100,000 pictures using underwater robots in the summer of 2010. But it's, all this data, and it's a really probably the best and most accurate representation of the whole field. I mean, there's been different sections, but this is the first time most likely that it's been the whole thing. Of course, this is one of those that is going to be a documentary on the April 15th, so it's, 100 years after. But it was sort of interesting to see both of these articles out this week where
you have
I'm
always
a very
sucker
accurate,
for that stuff.
I know. So am I.
I had an experience. I must have been in Vegas, and they had some sort of Titanic exhibit there, and they had all kinds of stuff from the actual Titanic, and then they had replicas of things and rooms, and I mean, you got to walk around in that fake. They rebuilt the staircase that is famous from the movie where Kate's at the top of the stairs. Really interesting stuff.
Yeah, I saw one of those, and I remember like at the very beginning, you were handed like a card. And that was like your name, and it was told you like you're in first class or you're in third class. This is your name, and then there was like a big title of names on that, and you have to find. You're like, where on the list are you?
Yeah, I was a survivor.
And it had a big sheet of. I wasn't.
Oh yeah, the buddy.
And there was a big sheet of ice that you could like hold on to.
They had a big iceberg there. That was a real iceberg that they had like machinery hooked up to keep it cold and frozen.
Yeah, and so you could like hold on to see like how long could you hang on to a chunk of ice.
Where did you see this? This must have been the same exhibit? It sounds like exactly the same thing.
Yeah, it was in Houston years ago.
Yeah, they travel around.
I don't even know when, but yeah, it's one of those that I was figuring that. I was like, it's the traveling exhibit. I saw that one.
It really is something. They had like a replica too of like a little model of the crashed boat, big enough though that you could really kind of look at it and it was really a pretty neat experience. And it's just, to me, it's fascinating because at this point, the Titanic, we're talking 1912. It's been 100 years ago. And yet it still totally captures my imagination.
Yeah, and it's one of these things that they're trying to grab as much data as they can about these fields. Also, because it is degrading.
It's interesting now that we have this technology. There are so many things over the ages that have been lost to time. That we will now, at some level, like we've never had before, be able to capture things. Like the pyramids. I mean, even now, if the pyramids are destroyed or if something happens, at least we'll have a lot of data that past versions of humans would not have had.
Yeah, I mean, it is one of the things where the more we can record, the more ability you are to look back. Because, I mean, so many, great palaces and all the Roman architecture, we kind of know roughly how it should be because there were drawings and stories of, this was here and, it was standing over the channel, one leg over, on one side, one leg on the other, totally gone. But, we have the drawings of what it looked like.
Yeah.
So we can kind of make interpolations of what was there. And this is sort of growing on that, where we're recording the world around us in such a way that, for future generations, no matter what happens to it as it degrades or as, things happen to it, they'll still be able to see what we had now and how it's changing over the years.
For any artwork that we have digital high resolution images of and all that kind of stuff, it's all going to be preserved in a way that previous art wouldn't have been preserved.
Yeah, it was a few years ago. I don't recall the name of it now. There was a giant tapestry. It had unicorn, and all sorts of other things. And they took it down, to give it, because it was hanging on the wall, so they wanted to take care of it a little bit. And they laid it down and they let it kind of settle out. And they was looking on the other side of the tapestry that had not been exposed to the light. And the colors were so much more vibrant. And they could see, some of the threads were actually very, silvery. And so they took all this digital imagery of it so that they would have that captured. Of course, they displayed it, with the exposed side still exposed. Because they want to, still keep the hidden side as well preserved as it can be.
Okay.
They took all these digital images of it so they can look at the more vibrant side, and have it available for people to look at. And also so, if something happens or if it degrades more, again, you have that snippet of time of where it is.
That's a pretty cool thought. That's pretty cool. I mean, that kind of leaves me with a sense that the ultimate outcome, which is human knowledge and the advancement of our civilization, think about the potential of rapid development down the road when we have all this stuff on demand, all this information. And for science, I mean, the innovations they can just continue to build upon now are just more accessible than ever.
Yeah, there is some, I don't recall where I saw it, but there's some evidence that the faster humanity can communicate, as communication increased in speed, the ability to new innovations came that much faster.
Sure, that makes sense.
because the faster that I can share my little bit of information with someone in Russia, they can build on it. And then someone in Australia can build on that. And someone in Ireland can build on that. And it's increasing the way in which people can look at new inventions and build on it.
And look at open source. It follows a similar model.
Yeah.
Interesting. I think I could talk for hours about how all of that is really going to change us forever.
Yeah.
But maybe more throughout future episodes. So what do you say?
Yeah.
Next story?
Yeah. Higgs boson, those crazy old God particles, as they keep saying.
Yeah, right. The God particle.
Yep. They continue to look for them. Fortunately, we've talked about it in other SciBytes. There's two new experiments that were looking at it, completely separate, different groups, different types of, they were using different types of data, looking at 4 different things. And through that, they were able to kind of corner the weight of what they think the Higgs boson should be. And they both kind of collaborated and said, hey, our data actually combines and makes sense. It says that the mass should be in this specific area. There's other things that have seen that. This is the December announcement in 2011 came and said, we think it should be in the weight should be in this range based upon decay patterns that we see. And these two teams independently comb through hundreds of trillions of proton-antiproton collisions reported by their different experiments and said the same thing. So it's interesting as more independent experiments come and say, this is the area that it should be. And each time maybe you take a slice out of that. You have this circle of where it should be. You've painted the floor down to there. And then maybe another experiment paints a little more in and paints a little more in. And so you're kind of really narrowing down where it should be, what it should be, when we could possibly see it. I think I've talked about this before, where it's like looking in a football field for like the one grain of grass that's like a little more greenery than the rest of the green. Right. And so, so we're narrowing down. We're like, all right, we can be between the 5 and the 7 yard line and sort of midfield. All right, maybe it's between the 5 and the 6 yard line and maybe within these 2 to 3 feet. So we're chunking it down so that we can only have to look at how many blades of grass are we having to look at? 1 million, 100,000, 100.
So they are narrowing it down then.
So yeah, we're narrowing it down slowly but surely. And it's always good to see when independent experiments either narrow it down more or say, yep, it looks like that's the area by our data too.
Right. That's, I think, even better in some cases. A secondary conferment like that to me seems like a pretty big deal.
Yeah.
So I guess I kind of lost track of what we get once we've discovered this particle. Does it give us like the
knowledge that it exists? Currently, the theories are that
okay, I see.
Yeah, the current theory is that's what gives mass to the universe. It is this random field it's like Higgs boson field of stuff, and everything moving through it slows down or speeds up depending on its mass, and that's what. Essentially, that's what gives it its mass. Think of, a big mall and you're walking through it. When there's not a lot of people, you can move quick, or traffic. And when it's rush hour or when there's, a blue light special, there's a whole bunch of people nearby, you got to move real slow.
All right.
So that's kind of the thing we're looking at, is that should theoretically give, by one theory, set of theories, is the mass of the universe would be from this. So we can prove or disprove its existence and kind of go from there with science. Be like, okay, it doesn't exist. Let's come up with another theory. Or, hey, it really does exist. Awesome. Now let's build on that theory.
I follow. Well, there you have it. All right. Well, so any other thoughts on that story?
No, it's just as we take one step farther, it's kind of a stepping stone, really, until they can get enough data to confirm or deny. And it's a lot of data between here and there, but.
And as long as they keep on the path of narrowing it down, it'll happen sooner than, or at least we'll get an answer eventually.
Yeah.
So that's not bad. All right, well then, what that means. It's time for the 2 news bites. 2-byte news. 2-byte news. With the new 2-byte news bump.
I see that.
All right, here we go.
All right.
We're now in the 2 news bite. Lay it on me. Or 2-byte news. I'm never going to get
2-byte news. Shorter stories. All right. talked about it before. Dinosaur feathers getting color.
Right.
We have another incident of that happening.
Oh, really?
We have American and Chinese researchers uncovered the color of a feather of a microraptor, pigeon-sized, four-winged dinosaur about 130 million years ago. And from this one, they were able to see that we talked about it last time, there's these pigment-bearing organelles in the structure of the wing, and we can see those from looking at the fossil record with electron microscopes and then comparing them to what we have nowadays, and they were able to match it up to feathers that are black with an iridescent sheen. So it's kind of it's an iridescent feather. And from that, they were able to get a lot about this bird dinosaur from it. They're able to say, hey, if this is what it is, then it's probably not a nocturnal creature. There's not a lot of reason. I mean, generally these kind of
to show up in the sun if it's going to be reflective like that.
Yeah, and generally that would be used for mating rituals or something along that. They'd kind of use it. They're also able to get a better idea of the tail feather, and they're able to kind of see that is actually too small to be used in flight. It's more like ornamentation, probably used in the courtship, just like the iridescent feathers. So it's another one of these where it's funny how they're able to use scanning electron microscopes and look deeper and deeper into these fossils and kind of use that, like in the feathers, to compare it to modern day feathers and say, what can we extrapolate about it? Can we line these up and say, hey, that's what this is?
And this whole getting back to I know we talked about this last time on what was it, SciByte 31, but I am completely just sort of blown away by the fact that our science is able to determine color from this, from now. I mean, this far out.
Yeah. Well, it is because there are like we've said before, and like we said this time, there are these specific pigment-bearing organelles. They line up in specific ways, and they look, they're arranged in specific ways.
Right.
This arrangement means this, and that arrangement means that.
It's like
we can
HTML
see it
color
in
codes for genetics.
Yeah.
But, it still really impresses the hell out of me.
Yeah, that we're able to see that close into fossils that are well enough preserved to see that.
Yeah. And that we know how to interpret the data. I mean, just even that too, just being able to see it and then, know what it means is significant, I think.
Mm-hmm.
Any other thoughts on that one?
No, I just brought it up again because it was another one of those times where it was interesting. I was like, wow, we talked about it not too long ago. Here's more feather colors, and this time they're shiny, iridescent.
Yeah, that'd actually probably be pretty freaky if that thing was coming after you and it'd be flashing in the sky.
Yeah, probably not that flashy, and I don't really know how flying it was.
Oh, really? Okay. So more like gliding maybe, or
sort of flopping wingy-ish.
That's not scary.
Nah.
That's just kind of sad.
No, it's pigeon-sized.
Yeah.
So.
Okay. So
there'd
have to be a whole bunch of them for it to become scary.
Yeah.
Yeah. Then it could become scary.
I mean, if it was, the birds dinosaur style.
Maybe,
then it'd be scary.
Maybe if they were undead too, that'd be scary. And if they ate brains, that'd be scary.
Yeah, birds 2, zombie invasion.
Right.
They're back. Right. Yeah, that would be scary.
Dinosaur zombie birds, that would actually kind of freak me out, especially in a group. Yeah.
Yeah.
All right, well, should we talk about transparent electrodes?
Yes. Scientists have shown that these ultra-thin sheets of exotic materials specific ones remain transparent. And layered in a specific fashion, they're highly conductive, even flexed or folded like a piece of paper 1,000 times. So they can make these 5-layer sandwiches made of alternating single atom sheets. So these sheets are only 1 atom thick. So 5 layers of it, you're talking about something 5 atoms thick. And so it's transparent.
You could
to light.
This is like the perfect kind of thing for really small surface electronics and stuff like that.
Yeah, or for solar cells.
Sure.
For anything like this. So it's they've also shown that it's bismuth and celandine are the two alternating things. They don't degrade in humid environments when exposed to oxygen treatments. So these kind of things that are out in the weather or common in manufacturing, they don't really degrade from that. So you could use it to solve problems with modern transparent electrodes. Cells, they're too fragile, they're not transparent enough. Solar cells, they're only roughly able to get half the solar energy that hits the Earth because half of it hits in the form of infrared light. And very few of today's solar cells are able to collect that. And these transparent cells will be able to collect so much more of that. Or using communication devices.
Oh, sure.
Infrared sensors. You could get more of the light through these. So they're just kind of looking at these, and I'm testing them and looking at the conductive electricity on the surface. It still remains very well, while the inside remains insulating, as good as gold in an electrical conductor.
Wow.
So all these kind of exotic materials are coming together to give us interesting. We've talked about one not too long ago where it was flexible, sensors.
Right.
We have these, transparent electrodes. So these exotic materials are kind of coming together in certain ways that really kind of interesting. And
will most likely be used in the product we'll actually get our hands on is the thinnest iPod ever. That'll be the application
the size of
we
a
see.
fingernail, and you'll have to buy them by the hundreds because you will lose one every half hour.
Right. And of course, the battery life hasn't been shrunken yet, so you have to dip your hands in battery acid.
Yeah, maybe. So you're gonna maybe use an electrode to tape it to your forehead or your earlobe, and it'll power itself on the heat of your body. And if you run a temperature, it's gonna run really long time.
Yeah.
And then people will try to get sick, so they'll be like, "My battery's low. I need to go run in the rain, catch a cold."
Maybe it's not such a good idea.
No, probably not.
Yeah. Well, maybe we'll see it in something else.
Yeah.
Well, interesting to note. Should we talk about the Martian dust devil that was caught?
Yes.
On camera.
Yes. We have seen these before. The rovers, the landers, they've all captured dust devils in action. Some people may recall one of them actually went over one of the rovers, kind of cleared off its solar cells.
Yeah.
They had a lot more go power, a lot more oomph to them.
Yeah.
So, dust devils, not tornadoes. They're just ground heated by the sun, warming, heating, rising with cooler air, starts to rotate. There's no cloud cover overhead that needs it. So this specific one was caught by the Mars Reconnaissance Orbiter.
Right.
Reconnaissance. I cannot speak science tonight. So this specific one was half a mile high, maybe 90 feet wide. So this is pretty interesting. The fact that these happen, it's not going to be as often as on Earth. Mars is farther away.
Oh, okay.
Less of sun's rays.
Mucking it up.
Yeah, less mucking it up. Now these dust devils are definitely visible because it can move the sand around, as we've seen from clearing off the solar cells. So it's kind of interesting that they spot these from the ground, they spot these from the sky, and this one was kind of cool because you can see the shadow of it.
Yeah, well, I mean, it's almost half a mile high. That's going to cause it. That's going to cast a shadow.
Oh, well, yeah. Half a mile high, 90 feet wide. It's big enough.
And then you have this you have the shot of a photo in the show notes, too, of, is this damaged Martian landscape? Or it's the damage, it says, enhanced image shows the dunes that are on Mars. Oh, yeah. I see.
Yeah, some of these, you can see the trails. So sometimes we're able to see them in action.
Tracks almost.
And sometimes you can see the tracks. There's one image that is kind of red, kind of normal Martian ground, and then you see all these black trails going across it, and that's where dust devils have gone through and turned up the soil.
Interesting. Mars is having a party all by itself. Nobody's there to see it, except for us now, sort of, by proxy.
If they invited some of us, we go.
Right. If Mars
they just
invites you
invited us.
to a Dust Devil party, you should probably go. That's
Invitations in the mail. It takes a while, to cross the barriers of space.
That's true.
Postal Service cannot guarantee 2-day delivery. Not a chance.
Those Martians ought to switch to email. So much easier.
I know.
Except for the connection speed I hear is pretty slow.
Yeah, that too.
Yeah, they have rough. Well, so there's a story in here about the fossilized circle of life. Now, I have watched my Lion King, so I think I know what you're talking about here, but fill me in.
Yes. Okay. So there is a fossil that's found. It was a pterosaur flying, 6-foot wingspan, probably skimmed along the surface of the water, grabbed fish. So they have that. They have a fish in its throat, that it's caught. And also a larger fish caught it.
Oh, I see. So that's the
that's the circle of life.
And then it
now,
got fossilized.
Yeah.
That's great.
Well, what happened is the larger fish was not going to be hunting pterosaurs on a regular basis. It's too big. The flying creature was too big. Wingspan just not going to work out. What probably happened is they're both probably going after the same fish.
Oh, sure. Yeah, that makes sense.
And they both had a very unlucky day, including the little fish. Because what happened is the wingspan was too big for the big fish to do anything with it. So it got stuck in its mouth like a fish hook.
You sure
I was trying to shake.
Now, are you sure this just wasn't like a caveman's early experimentation with like their version of the turducken gone wrong? Because maybe we got this all wrong. Maybe some caveman was going to have himself a fantastic meal.
If only my face could transfer through audio form.
I mean, is that a face of like, yeah, that's a great point, Chris? That's probably what your face was, right?
No, I can't even be. I can't even pretend or be sarcastic on that one.
All right, okay. So you don't think that's what it was? I take that. Okay, I'll get that.
Probably not. Only because this was in mud and it was in the bottom of a lake. Because when the big fish caught it, couldn't shake the pterosaur off, and so it wasn't able to eat the pterosaur. Then they both went to the bottom of the lake, drowned, and fossilized, and came for Chris to think it was caveman turducken.
You never know. I just, I've been doing the paleo diet. Some people call that the caveman diet, and so I've had to think more like a caveman. So I've become in touch with the creative things you can do on this diet. That's all I'm saying.
Fort from the chat room more accurately calls it the taro fishing.
I like that. Yeah.
Because there's no turkeys or ducks.
Right.
It's all taro fishing.
Yeah.
There we go.
That's a good point. Well, now this next story, I guess you were tracked down by members of the Jupiter Broadcasting community to make sure that you knew all about it for this week's episode of SciByte.
Yes.
So what's going on?
Apparently in the last few days, Alan from TechSnap was talking in the chat room and said that he was looking at a clock that was even more accurate than anything else because it was watching the neutron spin around the nucleus of an atom.
How is it doing that?
Yeah, everyone in the chat room called him out on his science. It was like, yeah. Neutrons are in the nucleus of an atom. You can't watch them orbit. That's electrons, silly. And so he kind of got knocked down. And it was funny because I saw the email from him before I heard about this. And so then I heard about this and I was like, I must go check this out. So atomic clocks, generally, they're measured the electron spinning around the atom. It's the oscillation that makes a natural vibration for an atom that they keep. It's like a pendulum on a clock. It goes back and forth, and you can kind of keep time with that.
You can very much keep time with that.
They do keep time with that. Very accurate time with that.
Not just kinda.
Yeah. Now what they're doing is they've used some lasers to fix the electrons in a specific orientation. Now they still want to orbit. So it's like if something's spinning and it has an inner, there's two systems inside. One of them is spinning. When you grab the outside and hold it still, the nucleus still wants to spin. It's going to send it spin instead of the electron spinning.
Oh, okay. All right. Now, is this because this is easier to observe?
It's not necessarily easier to observe, but what they can do is they hold the electrons in a specific area, and then they can watch the nucleus rotate. This is like, on a large scale, think you're very far away and you're keeping time by watching the orbit of the moon.
Okay.
And you say, okay, that's that. Now, what is also happening is there's a lot of external forces going on, and they affect each other, and so it's not quite the same. Its oscillation is taking into account a whole bunch of external perturbations going on. Now, if instead you were able to look at, say, Mount Everest, it's not orbiting the Earth,
Right.
but what it is orbiting is the center of mass of the Earth.
Okay.
So you can watch that go around the center of the Earth, and you can count that for days. And it's going to be more accurate because there's going to be less going on than watching the moon. The moon going around, it's going to, both of the Earth and the moon wobble.
Yeah.
But
exactly.
watching Mount Everest,
Right.
It's much closer. So it's going to be more accurate. So they're able to hold the electron still, watch the neutron spin around this. I mean, it's because it's like the Mount Everest. There's still a center of mass of the atom. The neutrons and positrons are still in there around the center of the mass. So we're able to kind of watch it spin. And they can watch that, and they can watch that oscillation. And it's like a much shorter pendulum. There's much less that can go on. And they're able to get it so accurate that over the course of 14 billion years, it would still be within 1/20th of a second.
Wow.
1/20th of a second over the age of the universe.
I think this is a lot of work that's being put into something for just some sort of concept that we make up on our own minds about how the universe works when it comes to time. I don't buy all this time stuff. I don't buy it.
Well, they are able to, the more accurate they can measure time, the more accurate sometimes specific scientific studies can be. If you can cut down time to even farther, then you can get more accurate measurements of what's going on.
Oh, absolutely.
And when it's going on.
Right. That makes sense. So that's why they go to all the trouble.
Yep. So
there you go.
Congratulations, Alan. I defended your brain honor.
Now, I actually think the funny thing about that whole story is that you guys got all giddy about a clock. I just think that's the funny part, but that's fine.
Science is cool, Chris.
Yeah, that's true. Heather, this jingle you're about to hear, right? Maybe. No.
Uh-huh.
Well,
maybe.
No.
Not. Maybe.
That one I was going to say was being timed by a new atomic clock, but apparently it got its... Oh, there it is.
Oh, there it
is.
I
guess see, that's why they need to start monitoring Mount Everest. Just want to take a quick moment and remind everybody out there who is a SciByte viewer or listener and also an Audible fan. Last week, I made my Audible pick for... I don't know. I'm giving time between some of these picks because I want to let you guys have time to actually experience these books, because this book I picked last week, 11/22/63, a novel, is a Stephen King book. I've never recommended a Stephen King book before, and it's 30 hours long. So I know it's going to take some of you a while to get through 30 hours, but I'll tell you what. I'm just reminding you because this book is one of the best books I think out there ever. It's like the book Stephen King was born to write, and I'm not just saying that. If you scroll down over at audible.com and look at the reviews, here's the title of this one: The Novel Stephen King Was Born to Write. You see what I'm saying? Exactly right there. This guy says, I wish I would have saved some of my stars on other books so I could properly represent how much I love this book. I mean, it's a really good book, you guys. And it's just an interesting, fascinating way to deal with time travel, the minutia of time travel, but also some interesting elements. In fact, I mentioned earlier in the show where in some ways history doesn't want to be changed, and there's some interesting ways that it pushes back. And simply put, he's trying to prevent the assassination of President Kennedy. And the way their system works is the bigger the event you're trying to prevent or change, the bigger the resistance in the universe is. And the mechanics that they deal with and all of that are just so mentally entertaining. They're just a treat for the mind. It's a fantastic listen because the guy that reads this book is amazing. It really is. He is amazing. He voices the characters so well. You hear there's some brutal scenes in there. I will warn you about that, but they're just so riveting. They're page turners. So, anyways, I just wanted to give you a quick plug for 11/22/63, a novel by Stephen King, and we have a link in the show notes. If you use that link, we get credit, and you also, if you're a new Audible subscriber, get the book for free, which you get to keep even if you decide not to keep Audible, which really... That's really saying something, because that's essentially giving you the book for free, because you could just get the book and then cancel if you wanted to do that. But you don't, because I'm going to give you more picks.
No.
I'm going to give you more picks once you guys get a chance to get through that. And honestly, once I get a chance to complete it. Oh, that's the SciByte computer reminding me that it's time for the spacecraft update.
Yes, I was frightened by the computer for a moment.
It's designed to wake you up. Also,
It definitely woke me up.
That's also designed to wake you up.
Yes. So we have got another upgrade on the Moon Probe's Grail, Ebb and Flow. This is the twin probes we've talked about before that are very accurately measuring, the gravity of the moon, looking inside it, trying to get some information about it. These washing machine sized things, and they've just begun to start their science mission. They've had their precision flying motion going on. Mapping phase will officially begin on Tuesday, March the 6th.
Oh, that's exciting.
So that's when it started. The moon cams, for the students that can take pictures of the moon, they were turned on Monday, March the 5th. All appears well with those images going on. So everything's looking green lighted for them.
Do they have plans to get, do you know of how, I guess I should back up. Are they very high resolution cameras? Can they get high res images of detail of the moon? Because I would love to see updated pictures of the moon landing, because then I could show them to all the people that say the moon landing didn't exist.
Yeah.
That didn't happen. You know what I mean?
Yeah.
If they could do that, that would just shut up so many people.
Yeah. Well, you'll hold that thought for maybe 5 minutes. But these specific cameras, no, these were kind of an addition. Sally Ride came through, first U.S. astronaut came through and said, hey, we should, do something for the kids and make them really want to go into math and science. So kind of these cameras were kind of put onto the satellite in addition to for students to pick what parts of the moon they wanted to take pictures of.
I really like that. That's fair.
So it's, there's very accurate scientific data going on, but it's not completely, there's facing the moon, there's a chance to put cameras on there. And it was sort of a dual mission so that you can hook on more. Why not? Mm-hmm. And get kids involved. Why not?
Mm-hmm. Mm-hmm. And I guess they're more interested in the kind of the cameras that would give them the kind of pictures where they can pull all kinds of data out. Whereas with visual, they just can only get. I mean, visual is helpful, but there's other types of images they can take where they can see, the types of material that are down there, the temperature of things, and the composition of things.
There are very specific orbiters for taking high resolution pictures. And this was just not one of them. This was just taking images of the moon. Kids can say, I'm going to take a picture of this crater or that crater, and it will go through and it'll do that. There are high resolution images that can offer the scientific community more information. This was just, it's one of those times where it's not the primary aspect of the mission. This is sort of an addition to inspire kids and get a little extra data here or there.
And the thing to always, I suppose, keep in mind with those is they only put the gear on there that they need for many reasons.
Yeah.
Just the essentials.
Yeah. So there wasn't a great deal of purpose to get that specific with those cameras.
And they'd help a brother out. That's all I'm saying. They could help a brother out.
Well.
Any other thoughts on that one?
No, it's just one of those updates where it's kind of, it has a specific lifespan. We'll kind of keep an eye on it as it goes and it gets more data.
So they won't stay out there for forevers?
No, this is one of those that is solar paneled. It's getting solar power energy. And there is going to be a lunar eclipse. So it will be blocked from the sun for a period of time. And that will probably maybe kill its batteries. From the cold, from the lack of energy. It may survive it, but they're thinking it probably maybe won't.
Stand by one, Heather. I have a light flashing on the SciByte computer dashboard. Let me see. It seems to be a level 1 master alarm. Oh! We'll take a look at that. It seems we have a little viewer feedback today.
We do. I hold you to hold your brain for just a few minutes because this story is archaeology in space.
In space!
Yep. Andy from the chat room pointed out a few good stories and books about space archaeology. This is, the idea that we can use satellites to look back at what we've done before, to look at the lunar landing sites. And exactly, the Lunar Reconnaissance Orbiting Camera. This is one of those that does have a high resolution camera. It dropped to an orbit of only 13 miles. Gave us the best imaging of the Apollo landing sites ever.
Why is it like a night?
I know. Let's see, what was it? It is in the multimedia room. The chat, the first link. It's really interesting because it shows, it's a slider.
I can make it.
Shows you kind of like,
yes, I can make it more high res or low or less res.
Yeah, the low res is what we had before. The high res is what we have now. And it's interesting because you can see the trails of where the astronauts walked. You can see dual trails of where they drove the buggies.
Yeah.
Because the wheels. And
it's funny
so
how close they really did stay. You know, I mean, for safety and all that. There's one track that goes way off for the buggy. Yeah.
I mean, you may not know, but I mean, the Apollo 11, the total area they were allowed to walk in could fit inside the infield of a baseball diamond. They were not allowed to go far. Actually, Neil Armstrong walked out to a crater. And that was like the farthest that was, that they went, and he wasn't supposed to go that far.
Oh.
He just couldn't resist himself and kind of went over to a little crater and there's a big panorama from Apollo 11, and that's where it came from. Now,
this is just so cool. And then they have a whole other set of images too.
Yeah, there's a couple of different landings, 11, 12, 14. 12 was interesting because it proved that they could precision land. They actually landed near a previous probe, the Lunar Surface Experiment package. So they're able to land near it. So they're going to say, see, we know where that was. We can land right near it. And in fact, people ask sometimes, is the flag still there? Now there is a lot of different things going on that nylon will degrade over time from it. But you can actually see on Apollo 12, you can't see the flag itself, but you can see the shadow cast by it. So you can see that at least on the Apollo 12, it's still kind of there. You can see a shadow cast from the flag.
Yeah, and it's in the shape of a flag. That's awesome.
Yep. Yep. Now this is one of those times where it dipped really low. It's not going to be this low again. The orbit just made it go lower. Now, generally, from its normal orbit of about 15 miles, you can get about, so it gets a certain amount. This time, since it was from the height of this lower orbit, gets you about 6 inches to every pixel.
Huh.
So it's very detailed, very gets down to it. That's why you can see, the 2 trails for the rovers. So you can see all of these in really high res. You can see it really detailed about what happened. You can see the dark tracks of where they walked, where the rovers walked, because it disturbed the soil on the lunar surface. So you can see the dark tracks, and you can see the shape of the descent stages and such.
I have to recommend everybody go to the show notes. If you're not watching the visually enhanced version of the show that we put up, you got to check out these images. This is a real treat. If you're like me and have always wanted to really see this, now you can. I mean, there it is. It's awesome.
I loved how they did it, the slider. So I sat there sliding back and forth, like looking really detailed. I'm like, how much can you see there? Oh, now you can see all this here.
Yep. Yeah, but it's like going from VHS to Blu-ray.
I know.
It's great. Well, very cool. Any other thoughts on that one?
We can see some things from Mars as well. We have a whole bunch of orbiting things. We can see, we've taken pictures of the Phoenix lander that landed near the pole.
Okay.
And from, we could see it in 2008, we could see bright and shiny solar panels. And in 2010, they were much dimmer. We could only see one of the panels, the other one just completely gone, blown away or what have you. So we can kind of see as things happen. We have used satellite imagery in conjunction with the rovers to kind of plan out where we want to go, to see where they are. But in general, the rovers and some of the landers that are smaller, we can see them for a certain period of time. We can kind of see them, but Mars has an atmosphere. Mars has dust devils. Mars has, sandstorms.
Right, stuff doesn't get preserved quite like it does on the moon, huh?
No, and things get covered with dust and it becomes much harder for them to be seen.
Huh.
But we have seen some things. We've been able to kind of make out where things are. And in fact, we use the satellite imagery to kind of say, this is kind of where we think this one crashed. Let's look for it. They haven't really been able to see those, but they kind of look in the landing crash areas. Like I said before, the weather probably won't allow us to see whatever's left. Is probably covered in dust. But it's one of those things that it's interesting. We can go back and kind of hope to see that stuff.
Yeah.
The lunar stuff, much more well preserved. You can see very detailed information about it, and so things like ebb and flow. We talked a little while ago. That was sort of an additional camera. This lunar reconnaissance orbiter, purpose built for taking images, and it just so happens that as it's stabilizing in orbit, it had a low pass, and this let us get really detailed images of everything that happened.
That's a joy. You guys got to check those ones out. Always great. Yeah. Always great show notes, of course. Always worth checking out, but for these ones in particular. All right. Any other thoughts on that story?
No, I won't admit how long I was distracted by sliding that thing back and forth before I actually remembered I had a show to complete.
Yeah, this episode, SciByte, if this one's late, you know why, folks, because I got a little carried away. All right, well, step on it over here because it's time to get in the time machine. Okay. And I don't want you to, because I know last time you got your foot stuck in the future, and that was awful.
Yeah.
So, all right, here we go. Come on, jump in. Here we go.
Okay.
All right, here we go.
Okay. Okay.
Gotta go far. Gotta go way back this time, way back. In fact, the science calendar, where we always look back in the week of science, the first destination takes us to 212 years ago, March 19th, 1800. What happened?
Electrical eels were captured for the first time. Alexander von Humboldt, Poland. I'm mispronouncing their names horribly, but they were on a 5-year expedition, checking out South America on their way to the Orinoco River, and they discovered swamps crowded with electrical eels. Now, they were, kind of investigating their behavior, and they received a massive electric shock. In fact, one of them reported severe lack of feeling in his joints for the better part of a day.
Oh.
And they actually learned that horses had been killed by them. And, they published an article in 1808, 8 years later. But they were sort of captured and studied and shocked people 212 years ago. This week.
There you go. That is really something. The 1800s got a lot more electrifying. All right.
Okay.
I know. I'm sorry.
It's okay.
The next one takes us to 86 years ago, March 16th, 1926.
A little bit of a jump ahead, and the first U.S. liquid fuel rocket launched by Robert Goddard. A lot of people know his name. The father of rocketry, as he is called sometimes. Had some very specific ideas on how to stable flight by putting the rocket ahead of the fuel tank, how to shield it, how to shield the lines for the gasoline fuel, the oxygen.
Very true, but it was the Germans who figured out how to make the nozzle of the injector so they had more go. I'm just saying.
Oh, yes. That was definitely true.
It really is an interesting period. That whole type of flight really kicked into a very competitive mode around that time, a little after that time.
Yes.
And
so it's kind of interesting because they actually had some photographic evidence of some of it. They were able to, like you were talking about the nozzle. He kind of melted the nozzle of this specific rocket. Went to about 41 feet, about 60 miles an hour, and the camera ran out of film. So no actual record of the flight remains.
Oh, what a bummer.
Always check the film in your camera. Mm-hmm. Even 86 years ago, trying to recall to do this.
Or in today's vernacular, always make sure you have enough hard drive space.
Yes.
Right? Before you go into something epic like that. Well, there you go. Yeah. Boy, that whole period of time with the development of rockets and then into World War II, there's another great opportunity for Audible. There's some really good ones on Audible about that. All right, Heather. Well, now that we've looked back in time, it must mean it's time to look up into the sky for this week.
That's right. Jupiter and Venus have been on our minds, and Friday, March 16th, they're starting to separate. You know, we got the closest 4 degrees apart, about tip of 4 fingers apart. Now they're starting to get a little bit more separated, but it's still a marvelous view. So you can still see them, spectacular. Even Southern Hemisphere friends can see it. Mercury, we've talked about him a couple times, still in the western horizon, kind of below and to the right of Venus and Jupiter, fading, so even harder to see lately. And Mars is out in the east during twilight, kind of low in the horizon, but Venus and Jupiter are definitely the stars of, well, planets of the night sky still.
I saw obviously today and for the last few days I've been trolling some of the space sections on Reddit, and a guy has a cat picture, and he says on there that Jupiter and Venus are exactly cat ears apart, and you go to the picture and it says cat, and for one ear, above one ear is Jupiter, and above the other is Venus, and they're exactly the length of his ears. But anyways, my point is that it's definitely going noticed, which is fun. Yeah.
One of these, I mean, Jupiter and Venus are the big bright ones, so anytime they're going to be close to each other, you know, and they were in conjunction with the moon as well, you know, a week or two ago. So any of these bright objects, when they get close together, very much so brings, you know, everybody's eyes to the skies.
I'm not the only one that loves knowing this stuff, too, because I've been noticing on Google Plus and Twitter, people are linking to this part in the show notes saying, check out, this is what you're seeing. So people are using it as reference, too, which is really cool.
Nice.
Yeah. So that's what we have to look forward to this week, huh?
Yes, we do.
Okay, well, you know me. I'm always happy when I get to sneak a peek at Jupiter.
Oh, yes.
After all, it is the namesake.
Yeah.
Well, Heather, I mean, this show has been outstanding because, A, we got the lowdown on what's going on with those solar flares, and B, I really have wanted to see high-resolution imagery of the moon landing locations, and boy, did you deliver on that one. I'm going to spend so much time looking at that.
I know. You're talking about it. I was like, pause that thought. We shall get to it in just a few minutes.
Yeah, that was fun. I was like, I wonder if she has a plan. Well, I've really enjoyed the show. So great episode. And everyone, SciByte comes out Wednesday mornings over at Jupiter Broadcasting. We release it in video and audio. The video version is essentially the visuals of the stuff that we talked about. But we put it out in audio because it really is an audio show, and we know that a lot of you out there like to listen while you commute. We also do this show live over at jblive.tv on Tuesday evenings at 7:30 Pacific. So be sure to join us live, and you can star in our chat room. All right, Heather. Well, we'll talk to you next week.
Alrighty.
All right, everyone. Have a great week, and we'll see you next week.